All right, so we're going to draw a ray diagram. And so the way this works is I need to draw a straight line. So we're going to come from the tip of this thing and draw a straight line here. Actually, that's not very straight. You want to get as precise as you can. So let's do it like, yeah, that's right. So I'm going to go from here right to here. Okay, now that's going to provide me with a little intersection point, and then that needs to come down from here through the focal point on the other side of the lens. And so that's the first line I need to draw. Now the next line that I need to draw, and maybe we'll change the color of it to, I don't know, like a dark blue, is we're going to go from here right through the center where the lens intersects our horizontal plane, and we want to get it as precise as we can. Now technically, wherever these two converge, this is where my pencil image should be. So I could draw the little pencil image like this. Okay? Normally when we do this, we draw like an arrow instead of a pencil. And so then this would be the image as it goes through a converging lens. To make sure I didn't make any mistake, we can draw a third line. Now the third line we'll make red. And that comes from the tip here, and it goes through this focal point here to the lens, and then we go from the lens, we draw a parallel line in this direction. Okay? And they should always, always, always converge at some point right there. Okay? So when you're done, they should converge at a point right there, and that's where your image goes. So this is an inverted image that is smaller, so the magnification is less than 1. Let's do one more so you guys get a hang of it. So again, I'm going to draw a straight line, and we'll do them all the same color this time. I'm going to go from this tip to the lens, parallel to the horizontal plane. Then from there, I'm going to go through the focal point on the other end of the lens. Okay. Then I'm going to draw another line from the tip of the pencil through the center point of the lens where the lens intersects with the plane. Now, that third line should converge here. So technically you could draw a ray diagram with just 2 lines, but to make sure, I'm going to draw from the tip of the pencil through this focal point until it intersects my lens right here, and then I'm going to draw a parallel line that goes right through there. Now where all 3 converge, that's where my image would be. So I could pretend that I have an arrow pointing this way, and so this should be about right here. So when you're at 2f, it looks like it's probably 2f. Okay? And you could verify that with the formula 1 over the distance of the object plus 1 over the distance of the image is equal to 1 over f. Okay, so you've got 2f plus 1 over 2f plus 1 over 2f is 2f over 2f, which is 1f. Yeah. All right, and then the magnification and everything will be something different. So let's do problem number 3 just for the fun of it. Again, I'm going to we'll do this one in red. We're going to go from the tip of the pencil to the lens, then from that intersection down through the focal point. Then we're going to go from the tip of the pencil down through the center of where these 2 intersect, where the lens intersects the horizontal plane. And then I'm going to draw a line through my focal point to where it intersects the lens. And then from there, a parallel line And as you can see, it's a little sloppy. So probably what I would do is go back and make sure that I drew my lines properly. But you could verify this. So if we think of this as being like an arrow, where this is the head of the arrow, then the head of the arrow would meet here, and it would be magnified and inverted. Okay? That's pretty much it. I want to do number 4 with you guys. Number 4 is a special case. You'll get an interesting thing here, and then I'll explain why. Again, I'm going to take my line and do a straight line. Do it in red. So I'm going to go from the tip to the lens, then from the lens, whoops, then from the lens through the focal point. Oh, shoot. All right. So from here, I'm going to come down. Oh, see, I already screwed that up. Gotta get rid of that. We want to be, well, it doesn't really matter, I guess, because this one isn't going to work out. All right, so from here, down through the focal point, and I'm going to draw this thing way, way down here, because you'll see something interesting. So now, when I draw from the tip through the center, guess what? Those two lines look like they're parallel. So where will those two ever intersect? How about never? I ran out of room. So those are never going to intersect. And so here's an interesting thing. If I have, if I think in terms of the distance of my objects, I've got the distance of the object plus the distance of the image has to equal 1 over f always. But the distance of my object from here to here, the distance of the object is actually equal to f. So I've got 1 over f plus 1 over the distance of the image has to equal 1 over f. Now, I don't know if you realize this, but what can I add to 1 over f to get 1 over f? This has to equal 0. So 1 over this, the distance of the image, has to equal 0. Well, that's good because this thing's never, ever going to intersect, ever. This is never going to intersect. These are parallel lines. So the distance for the image technically is an infinite distance away. That's the only way you can do that. 1 over infinity is the same as 0. Right? So if you take one pizza and you divide it into an infinite amount of slices, the size of the slice would equal 0. Okay, so that's a special case. That's the only time you get that. Okay? And that's how you draw ray diagrams for converging lenses.